Alright everyone, welcome to our first video of the week. In this lesson I'm going to review areas and perimeters of similar ratios. So far we know that the relationship between the side lengths and similar fingers, we know what it's called, and we call it the scale factor. So let me write that down. Also known as the scale factor. And in this case, for example, to get from 4 to 16, multiply by 4, and to get from 3 to 12, you multiply by 4. So our scale factor in this case equals 4. And I think all of us got that down. Another way to do it is pick the corresponding sides. So 16 divided by this one, which is 4, or 12 divided by 3, which is again 4. And it doesn't necessarily matter which way you do it. I usually like doing the big one divided by the small one because it gives you nice whole numbers. However, now, we're going to go into finding the relationships between perimeters and figures of areas. So let me go ahead and erase this. Boom, 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 boom. This is going to be our main question that we are going to work on today. But first, how can we find the perimeter if we don't know the side? So I'm going to go ahead and add a question here, see if you can figure it out. But I will tell you that you're probably going to have to use a squared plus b squared equals c squared if I told you that this was a right angle and this was a right angle. So go ahead and try that, submit your answer, and then we'll come back. Awesome. So for the first one, I'll go ahead and do it over here on the side. Let me move this over. 4 squared plus 3 squared equals c squared. And the reason I'm doing this is because for the perimeter, it's when you add every single side. So if I want to add this side plus this side plus this side, I don't know it, so let's figure it out. So 4 times 4 is 16. 3 times 3 is 9 equals c squared. 16 plus 9, we can now do it as 25. And the square root of 25 is 5. So now I know that this right here equals 5. Similarly over here, if you want to go ahead and pause it, but I'm going to call this one C and try it by yourself. It'll be very, very similar. 16 squared plus 12 squared equals C squared. 16 times 16 is 256 plus 144 equals C squared. 256 and 144 is 400. Of course, I'm using a calculator for this. And the square root is 20. Boom. So now that I know all the sides, I know that for these, first of all, let me go back to this. The ratio, the scale factor, the ratio of the sides is going to be the scale factor, which in this case is 4. The perimeter of the small one is going to be 3 plus 4 plus 5, which in this case 5 plus 4 is 9, plus 3 is 12. So for the small one, I think on your paper it's the other way. So let me go ahead and fix that. For yours it's going to be large over small. Your perimeter for the small one is going to be 12. And for the big one, let me change the colors. 16 plus 12 plus 20. 16 plus 12 is 28, plus 20 is 48. 48. Now the ratio, very similar to the scale factor, is 48 divided by 12. So in this case, it is 4. It's not a coincidence that the ratio of perimeters and the ratio of the sides, also known as the scale factor, is similar. Now for this one, instead of finding the perimeter, we're going to find the area. And again, I'm going to ask you to do this by yourself, but I'll give you a tip. The area of the base times height, area is base times height divided by 12. So for this first one, base, let's call it 4. Height, let's call it 3. Remember, these are right triangles. So 4 times 3 over 2, which is 12 over 2, which is 6. So the area for the first small one Again, let me fix this one for you. Sorry, it's going to keep coming up like this. Large and small. The area of the small one is 6. The area of the big one is going to be 16 times 12 divided by 2, which is going to be 192 divided by 2. Or in other words, if you simplify that, 96. So this one is going to be 96. Similar to before, 96 divided by 6 is 16. Go ahead and see if you can find any patterns. I'll pause the video and I'll have you describe what you know so far before I continue on to the classwork. Alright, so now it's your turn. Go ahead and try this out on the problems I gave you. There should be 6 examples. Some of these will be hard, but I know that you can find a permanent area. You did it last year, so I know you can do it. And then after you have submitted your answers online, you will be able to see the answers to see if you are correct. And just to double check your work, here are the correct answers. Look at the patterns. Let's see if you can figure it out by yourself. But notice how one obvious pattern is that the scale factor is actually always going to be the same as the parameter ratio. And the scale factor is related to the area ratio. But let's see if you can figure it out by yourself. How do you get from 3 to 9? How do you get from 2 to 4? From 8 to 64? Or from 1.67 to 2.78? Alright, so we're almost done. We probably won't get to this part of the lesson, which is completely okay. But let me go ahead and skip to the next one. So if 2 polygons are similar, their corresponding side and perimeter ratios all have the same ratio x, also known as a scale factor. And here's a visual of what that means. The ratio between the scale factor to the perimeter is x to x. In other words, it is the exact same. Similarly, the area is equal to the square of the ratio or the scale factor x. So if we know that this is the x and this is the x squared, this is the scale factor and this is the area. Now, we probably won't get time to do this today, but we'll definitely have time to finish it tomorrow. And again, last part, you probably won't get time to do this, which is completely okay. We have a lot to do today. But if you do, go ahead and answer these questions on your piece, on your notebook.